Okay, as the final part of the basic math, we are going to think about logistic function. Logistic function has like a starting and capacity. So it does not exceed the capacity. So the form is looks like capacity 1 over 1 plus e to the negative some exponential. So this numerator 1 represents capacity. So it looks like this one is starting from that not really 0, but almost 0 to almost 1. Looks like it can represent a probability between 0 and 1. So we're going to use a logistic function a lot in our neural net. So we call this one as a sigmoid function. Also, we may use a binary like a true or false, or some simple linear function or something. So we can call this kind of function as a ramp, like just directly jump, or step function. So we can use a step function or we can use ramp function. So there are two sets of functions we're going to use to activate our neural network, but that's a little bit later. So we're going to go back to our math part again. If you look at the example 4, f of x equals 1 over 1 plus e to the negative x, logistic function, then how can we find the derivative of this f of x? First, we can use implicit differentiation. We do not like the denominator, especially when it has more than one term. So we're going to multiply denominator both sides. So y times 1 plus e to the negative x equals 1, and implicit differentiation. If we do derivative, it will become y prime, because it's a product rule, y times 1 plus e to the negative x plus, then plus y times, then inside of 1's derivative, so negative e to the negative x. Derivative of 1 is 0. How can we simplify this one more? First, you probably want to subtract the second part, both sides. Then you're going to divide by 1 plus e to the negative x. So finally, you're going to keep only dy over dx, so only y prime on the left side. So if you look at the right side one here, I am here, y prime is y times e to the negative x over 1 plus e to the negative x. Wait a minute, e to the negative x, I don't know, but if I change this one to 1 plus e to the negative x minus 1, that's the same. Then when I rewrite this way, I can see 1 plus e to the negative x minus 1 over 1 plus e to the negative x. So I can rewrite this one as 1, same thing, numerator, denominator, minus 1 over 1 plus e to the negative x is y. So I can simply write y times 1 minus y. So y prime is y times 1 minus y. How about when we have a little bit more complicated, like a transformation happened? 1 down and scale factor is 2. How about in this case? In this case, you are going to set the special thing as like when you add 1 to the both sides, y plus 1 equals 2 over 1 plus e to the negative x. So you are going to set y plus 1 equals 2 over 1 plus e to the negative x. So use this one. Now let's go back to our derivative way. Y plus 1 times 1 plus e to the negative x equals 2, then implicit derivative again. So y plus 1's derivative is just y prime dy over dx. Then 1 plus e to the negative x, you just write down, plus, because it's a product rule again, y plus 1 stay there, then derivative 1 plus e to the negative x is here. Now, right side is 2's derivative is just 0. Then, by using y plus 1 is 2 over 1 plus e to the negative x, you can rewrite this one in the next way. I want you to think about how you go to here. You can do it. Then, if you simplify this one, The first one will be 2 times 1 plus e to the negative x over 1 plus e to the negative x squared. So that is y plus 1. If you simplify, cancel out something, then minus 2 over 1 plus e to the negative x squared. So if you have 2 more, that is 4 over 1 plus e to the negative x squared. That means y plus 1 squared. So we did the extra multiply 2, so 1/2 is a front. Then if you simplify all of them, finally you are going to get y prime is 1/2 times 1 plus y squared. So we are just done basic math.